Discussion of the pop quiz. This is physics pop quiz 2. Past paper pop quiz 2. Okay.
Paper pop quiz 2.
Okay. The question 1. A knife is being sharpened on a rotatory sharpening stone. A spark flies off and lands on the operator's hand. The spark is very hot, a very small piece of a metal. Operator feel nothing. So if the operator feel nothing, what does it means? What it shows that this does not carry too much energy or does not store too much energy. Because if anything is hot and still we don't feel that effect. So if we don't feel that effect, what does it mean? It means it has a very low thermal capacity or store a very small amount of energy. It's a metal piece is there, so definitely it should be a conductor. So C and D are totally wrong. Like it's a good conductor is right option, but it is not related to the transfer of energy here. So even though it is very hot, but the person does not feel anything. So if a person does not feel anything, if an object is hot, so it means that the object which is in contact is having a lower thermal capacity or a lower amount of energy it absorbs. That's why we don't feel anything. Like if I'm touching this cup and I don't feel that this cup is hot. So what does it shows? It shows that this having a low thermal capacity. That's why I'm not able to regain that energy.
My laptop is high from my cup.
Question 2. Four blocks made up of different metals are each given the same quantity of energy. Which is having the greatest thermal capacity? The thermal capacity or the specific heat capacity, thermal capacity and specific heat capacity is inversely proportional to temperature change. If an object shows a smaller change in temperature, it will have a higher thermal capacity. So which block is showing the smallest change in temperature? Which is showing the smallest change in temperature? A shows the smallest change in temperature. So if the temperature change is small, the thermal capacity will be high. And which is having the lowest thermal capacity in this? D will have the lowest thermal capacity because D will show a greater change in temperature. If it show a greater change in temperature, it means it is having a lower thermal capacity. So the thermal capacity and temperature change is inversely proportional, or the specific heat capacity and the temperature change are also inversely proportional. Question 3. A long thin bar of a copper is heated evenly along the line. Whenever we heat, what will happen? The substance will expand. So which one is showing? It become lighter? No. It become longer? Yeah, that's right. Because an opposite will happen if I cool down this rod. What will happen? It will become shorter. It will contract. So on heating, a substance expand. On cooling, the substance contract.
It becomes like a fruit, right?
No, not like mass zones. The density will change, but not the mass. Like if this rod is, let's say, 20 grams, so it will remain 20 gram. But the size will change. Density is mass over volume. So if the volume increases, the density will decrease. So density, yes, it will change, but not the mass. Mass of an object does not change if the amount of matter does not change. Question 4. A block of ice is heated until it melts and the water that is produced is then heated until it boils. Whenever there is a change in state, is there a change in temperature? No. Whenever state changes, whenever a solid is turning into a liquid or liquid is turning into a gas, there will be no change in temperature. So temperature of ice when it is melting, it will stays the same, does not change. Temperature of a substance when it is boiling, stays the same. Why the temperature is not changing? Because whenever there is a change in state, the energy is supplied to break the bond between the particles. Like particles have bonds. So when the state is changing, all the energy which is supplied is used to break these bonds or overcome these attractions. That's why when solid turn into a liquid or a liquid turn into a gas, the temperature does not change. So if I say the temperature of ice which is melting, it is 0. What will the temperature of a water it produces? That will also be 0. So same temperature, only the state changes, but the temperature does not change. In question 5, 1 kilogram of a water and 1 kilogram of aluminium heated to a same temperature and then allowed to cool. Why aluminium cool more quickly than water? So cooling, it depends on the specific heat capacity or the thermal capacity, and which is inversely proportional to temperature change. Because as I mentioned, aluminium cools more quickly or aluminium show a greater rate of change in temperature. So if the change in temperature is greater, the thermal capacity will be lower. So which is the right answer? So aluminium will have a lower thermal capacity. That's why aluminium will cool down faster than water. So if you have two substances and you want to compare which is having a higher thermal capacity, you just compare, or you want to compare which is having a higher specific heat capacity, you just compare the temperature changes. Let's say both started with a temperature 20 and cooled down. So this decreases the temperature by 18 and this decreases the temperature by 17 to 17. So which is having a higher thermal capacity? This temperature change is 2 degrees. This temperature change is 3 degrees. So which is having a higher thermal capacity or a specific heat capacity? So A is having a higher specific heat capacity or thermal capacity. So specific heat and the temperature change, or thermal capacity and the temperature change, are inversely related to each other. Next, we have a question related to the space physics. Milky Way is one of many billions of galaxies. Each galaxy contains many billions of stable stars. Stable star transfer energy into the space by emitting an electromagnetic radiation from their surfaces. Describe what happened in the core of a stable star to release energy that is eventually transferred into space. So what happened? How the stable star is producing energy, by which reaction? By nuclear fusion. And what happened in a nuclear fusion? The lighter, yes, yes, hydrogen, specifically you can say hydrogen. I was writing in general, but you can say hydrogen, lighter nuclear, hydrogen nuclear, same thing, join to form heavy nucleus, such as helium, and release energy in the form of electromagnetic radiations. So in the core of a stable star, if it was a red giant, then how it will produce energy? By which fusion?
Nuclear fission.
No, it will be fusion as well, but which element? If it was a red giant, helium fusion. And if it was a supernova, then heavy elements.
Carbon.
So stable is always hydrogen, red giant and supergiant helium. And if a supernova happen or occur, that will result in a heavy elements.
So what's the proton?
Helium with helium means 2, 2, so it will form 4. Beryllium will be formed. On the Earth, light from a distant galaxy is observed and analyzed by the astronomers. This information is used to determine the speed at which the galaxy is moving from the Earth. So we can use this Doppler effect, or we can also use this Doppler shift, to work out the speed of the galaxy. Describe how the observed light is different from when it is emitted. So what will happen? Yeah. So we have to describe how the observed light is different from what is emitted. It depends on, in the question they mentioned the galaxy is moving away. So if the galaxy is moving, what will happen? It will be a redshift. The wavelength will change. The wavelength received by the observer will be longer than what is emitted from the star
It's like this. I have no idea. Bro, I'm not trying it.
What? No, here not CBR. Because what will happen? What will happen? We are observing the nearby galaxy, or we are observing a galaxy, and that galaxy is moving away from us. So this galaxy is having different elements. When we are observing the element, like let's say hydrogen, we are observing in our lab, and the hydrogen we are observing from this galaxy. So the wavelength of the hydrogen, a certain wave, so each element is having a unique wavelength that is also called a fingerprint of that element. So let's say it was 500 nanometer in the lab. So when we receive the same wavelength from a hydrogen, it won't be 500, it will be shifted longer. So let's say 520 nanometer. So if it's appear to be longer than what it should be, we conclude that this galaxy is moving away from us, and what we call that as a redshift. Okay. And opposite will be there if we observe the wavelength which we receive appear to be shorter than what we expect. Then what we conclude? We conclude that this galaxy is moving towards us, and it is known as the blue shift. So we have both red and the blue shifts are there according to the motion of the galaxies or the stars which are around us. State the quantity that astronomers use to determine the speed at which the galaxy is moving away. Which quantity?
Change in wavelength or frequency.
Yeah, which quantity? Hubble, you can like state the quantity the astronomers use to determine the speed at which the galaxy is moving away. Look, using this, it's already mentioned here in the question. If you read the question, on the Earth, light from a distant galaxy is observed and analyzed by astronomers. This information is used to determine the speed at which the galaxy is moving. So the same thing, state the quantity that astronomer use to determine the speed at which the galaxy is moving. So they use, this is called a Doppler shift or a red shift.
What's this?
Or you mention about the Hubble constant. Hubble constant is also related because the speed of the galaxy is the Hubble constant and the distance of the galaxy from us. But for that, you should know the distance as well. But the directly using a red shift, using a Doppler shift, we can, because if I want to use a Hubble's constant or Hubble's equation, V is equals to H naught D. I have to calculate, like Hubble's constant is there, but I should know the distance of the galaxy, and then I can determine the speed at which the galaxy is moving. So Hubble's constant 2.2 into 10 to the power minus 18, second inverse. So the best what we can determine is a Doppler shift. Using a Doppler shift, because what is a Doppler shift? The Doppler shift is given by Z. You're not learning the calculation of a Doppler shift, but the idea. The Doppler shift is a Z, which is the speed of a galaxy divided by speed of a light. You're not learning this formula. So when the speed of a light is multiplied by the Doppler shift, we get the speed of the galaxy. So which quantity we need to determine the speed at which the galaxy is moving away? We need a Doppler shift. How much the wavelength has shifted or the change in the wavelength. Like when we are observing the wavelength on the Earth, it is 300 nanometers. When we are observing the wavelength from the galaxy, let's say it is 330 nanometer. So what is a Doppler shift? The Doppler shift is the change in the wavelength compared to the original wavelength. That is a Doppler shift. So if we know the Doppler shift and we multiply by speed of light, we'll know the speed of the galaxy. But calculation, you don't have to learn any calculation of a Doppler shift. The conceptual, the only qualitative analysis is there, not the quantitative. Like you're not supposed to solve anything related to Doppler shift. Okay. But the concept of a Doppler shift, that the wavelength appear to increase when the object is moving away or towards the observer. I just discussed and recorded. Yeah. A Hubble constant is H naught. A Hubble constant is h naught. For those who just joined now, this session is recorded, so you can check the recording. So h naught is equals to 2.2 into 10 to the power minus 18 per second, or second inverse. Calculate the distance from the Earth of a galaxy that is moving with a speed of 1.3 into 10 to the power 7 meter per second. So the formula which relate the speed and the distance, v is equals to h naught d.
Yeah.
So if I need the distance of the galaxy, it will be v divided by h naught, where v is the speed of the galaxy. So the speed of the galaxy is 1.3 into 10 to the power 7. H naught is a Hubble's constant, 2.2 into 10 to the power minus 18. And d is a distance which we need. So this is multiplied, other side will be divided. So 1.3 into 10 to the power 7 divided by 2.2 into 10 to the power negative 18. So 5.9 into 10 to the power 24 meter. Calculate an estimate for age of universe and give your answer.
5, 8.
What? No, we have to calculate an estimate for the age. So you have to show that. So how you get the age of the universe? The age of the universe is reciprocal of the Hubble's constant, 1 over Hubble constant. So 1 over 2.2 into 10 to the power minus 18. What will the answer?
5 into 10 power 17.
So 4.5 into 10 to the power 17 seconds. That is the age, but we need in years. So then what we have to do, we have to convert the second into years. So second into minutes, what I will do?
12, 12.
So I'll divide by 60. Divided by 60,
And,
divided by 24,
and 360.
divided by 365. Because second, minutes, hours, like days and year, 365. So when we divide, what we get, we'll get
1.4 probably by 10 power 10.
so 1.44 into 10 to the power 10, or you can also, yeah, this is in year, or you can also say 14.4 into 10 to the power 9 years. Same thing. But if you got 1.4 exponent 10, that is also fine. We are not supposed to convert into billion. It's fine. Is it clear, this one?